Good day to all. Now we are going to learn about the thread concept in operating system. So first one is, what is thread? A thread is a basic unit of CPU utilization. Thread comprises thread ID, program counter, register set and stack. It shares with the threads belonging to the same process, its code section, data section and other operating system resources such as open file, signals, all can be shared. This is an example for the threading on a thread structure. We have two types of threads. The first one is single thread and the second one is multi-threaded. The first one is single threaded. It is a traditional thread method. It is a single thread of control. We can execute the single thread in a dedicated processor. Okay. So in the single threaded, it has code, data, files, registers, stack, all are dedicated to the single thread. Next one is multi-threaded. In this concept, we can share the code, data and files for the all threads, and in these each and every thread has a dedicated stack and a register for storing purpose. In multi-threaded concept, we have different models. First one is many to one, one to one, many to many models. The first one is many to one model. It's only one thread can access kernel at a time. In this image, we have multiple threads. Many threads can try to access one kernel thread. These threads are called the user thread. This thread is called the kernel thread. User thread can access the kernel thread. So if I want to, if many threads wants to access the a single kernel thread, means automatically it will scheduling and execute one by one. So once I want to execute this thread, means it will be allocated to the kernel and execute once. After this completion of the thread only, a second thread can be executed. Just like that, we can execute all other threads. But all threads has been waiting for the completion of other thread. And next one is one-to-one thread. In one-to-one thread means all threads has the dedicated kernel threads. So automatically all threads can be executed simultaneously. This one is a very fast more than the many-to-one method. And finally, many-to-many thread concept. So in this model, we have the many kernel for execution and also many thread can be accessed these kernels. So based on this method, which kernel is free means automatically the threads has been allocated and also the executed. So nowadays we have used the many to many thread concept. In many to one thread concept, if the thread has been blocked, this kernel means all other thread has been blocked, which means the entire system will be blocked. This is a main issue in many to one modeling method. So nowadays we have used one to one and many to one threading concept. Thank you.